Hello, this is Taylor Balker, and I'm going to be presenting Lab 3 of Physics 2212, the magnetic field of a bar magnet. The purpose of this lab is to measure the distance dependence of a bar magnet's magnetic field and compare this to a calculated computational distance via the B.S.Savart law. We will use these equations to find the distance in the magnetic field. We will also calculate the magnetic dipole moment due to the bar magnet. After all our calculations, we find that the calculated dipole moment, mu, is equal to 3.206, and the distance is calculated as 0.261158. Now let's take a look at our experimental model. To set this up, we needed to find the magnetometer on our phone. To do this, we used a magnetometer app, a meter stick, and a bar magnet from the mobile device and calculate the magnetic field at each distance d. We can then find the magnetic dipole moment by calculations, and this is going to be used in our computational model. The results from the experimental model are shown to the right. As we can see, we can calculate a magnetic dipole moment, mu, using the equation for the magnetic field. We find that mu is equal to 3.206. Now let's use our computational model to find a distance d. From our computational model, we can see that the blue arrows represent the magnetic field on a perpendicular axis. These point in the direction of negative mu, whereas orange shows the magnetic field on a parallel axis and points in the direction of positive mu. We can see the change in direction of the magnetic dipole moment as we change our observation location. Our computational model calculates a distance d equals 0.261158. So now our what-if questions. What if I hadn't accounted for magnetic north? Both magnetic fields would be superimposed, and mu would have changed in this case. Now what if I used two bar magnets instead of one? Well, it depends. The magnetic fields would superpose depending on the orientation of the bar magnets. So if it's in the same orientation, they would add together, but if they're in the opposite orientation, they would counteract each other. Some errors and limitations include that the magnetometer is not exact, our smartphone/mobile devices are not correctly oriented, and other magnetic/electric fields could interfere with our results. Thank you for listening.